Hi, Honors Geometry students, this is Mrs. Preach. We have made it to lesson 13.4, all about parabolas, and the diagram in front of you shows a curve of a parabola here, and there are some significant pieces of this parabola that I do want to talk about, but before I do, I'm actually going to skip a few slides back. This is not in your notes, but don't worry, just look up at the screen as a reminder of the conics that we have talked about already. The first is being a circle, and this picture of a circle is here because I just want to remind you that when you stop at any point on the circle, that point has an equal distance away from the center as any other point that you stop on the circle. So from here to here, this distance would be the same as this distance, which would mean D1 is equal to D2. So the definition of this circle is basically where all the radii are congruent to each other. And moving on to a picture of an ellipse, I just want to remind you that wherever you stop on the ellipse, let's say point P, if you take the distance from point P to one of the focus points, and then you add the distance from point P to the other focus point, that means you would add D1 plus D2. The sum of those distances would always be constant no matter where you land on the ellipse. And as another reminder, our hyperbola here, which are these two curves, remember no matter where you stop on the hyperbola, let's say you stop at point P, if you find the distance from point P to one focus point, let's call that D1, and you find the distance from that point P to the other focus point, which let's say that length is D2, when you subtract the distances, larger minus smaller, you will always get a constant number. Again, that's anywhere along either of these curves of the hyperbola. Which brings us to a parabola. And if I stop anywhere along this parabola, what relationships can I state? Well, if I stop here at point A, and I find the distance between A and the focus point inside of the parabola, so there is one focus point inside of my parabola, if I take this distance, which we call D2, and I add that to this distance here, which is the distance from the point to this line is called a directrix. It is a characteristic of a parabola that we'll talk about more in detail later. But when these distances are equal, then you will always lie on this particular parabola. And so as I move down the curve and up the curve, if I have a point here, again I'll repeat, the distance from this point here to the focus would be equal to the distance from this point here to what we call our directrix line. Those distances would be equal. And I do then want to mention when I travel back down and I get to this point here, it's actually not labeled, but this is called the vertex of the parabola. If you want to write it in, you can, but it's in our next diagram. So this would be the vertex here of our parabola. The same rule applies. The distance from this vertex to the focus point, which is labeled with a P, this distance here, would be equal to the distance from this point, which is our vertex, to the directrix line, which tells us something important, that the focus is always the same distance away as the directrix line, but in opposite directions. And so if you start at the vertex and let's say you travel P units up to get to the focus, then you would travel P units down from the vertex to get to the directrix. And therefore that makes the vertex really the midpoint between the focus point and the point directly below on the directrix line. And so under this, it says, for the curve to be a parabola, the distance from any point A on the curve to the focus and the distance from point A to the directrix must be equal, so D1 would equal D2. Just to mark that for you, that would show this is congruent to this. And to show that where our P values are, that also means this little length is congruent to that little length. All right, so let's look at the definitions a little bit more carefully again, and I'll go ahead and read through this. It says a parabola is the set of all points in a plane that are equidistant, that means equal distance from a focus, which is a point, and a directrix, which is a line. And so I'll show that in the example again. You can travel kind of up and down this parabola, but when you stop at point A, let's say, point A would have to be equal distance from the focus point inside the parabola, and it would have to be equal distance from that point to the focus point, and then that point to the directrix line. Let me see if I can highlight that there so that those distances would be equal. This must be equal to this for point A to lie on that parabola. Now, it also says, oh, sorry about that. So the next line says that the focus, which is a point, lies on the axis of symmetry. So we didn't talk about that in the last slide, but right here is what we would call the axis of symmetry of the parabola. It passes through the vertex here, which happens to be at 0, 0, and it passes through our focus point. And what this line does is it basically divides our parabola in half. So I have two symmetrical sides. This is called the axis of symmetry, another important characteristic of a parabola. There is also the directrix, which is a line which is perpendicular to the axis of symmetry. And so when you look at the diagram here, we talked about how if we start at the vertex and we go up a certain amount, that's how much it takes to get to the focus point. We want to travel that same distance below the vertex to get to the directrix line. So if I notice that my focus is at 0.01, that means our length there is 1. This length here is 1, which means I would drop 1 to get to my directrix line. And that is why this line has an equation of y equals -1, because it passes through the y-axis at -1. And also notice that this directrix is perpendicular to my axis of symmetry. And lastly here, it says the vertex lies halfway between the focus and the directrix. We've talked about that already. This vertex lies halfway between the focus and the directrix line. Okay, next, let's talk about P. P is very important. It's actually in the equation when we write the equation for a parabola. It's in the standard form equation. So P, what is P? Well, P is specifically the distance from the vertex to the focus. So vertex to the focus. And also the distance from the vertex to the directrix. So right here, this P, this is the length of the vertex to the focus. This would be congruent to the length from the vertex to the directrix. And so I can mark those two pieces equal. However, there is something else that we need to talk about when we talk about P. P is a length, so it's always positive. This is a P distance, and this is also a P distance. And they are both positive because length is always positive. However, P can be negative or positive depending on if the parabola is up or to the right or down or to the left. So here is the rule. The distance P is positive for a parabola that is up or to the right. I'll highlight that or underline that for you. So P is positive for a parabola up and to the right. And in this example, because our parabola is up, P would be positive in this example. However, if my parabola was facing down or facing to the left, my P value will actually be negative. Not because the length is negative, but because we are trying to describe the way the parabola is facing. Okay, so negative for a parabola that is down or to the left. Okay, so one more diagram. The more you see these pieces of the parabola, I think the easier it is to of course, understand how to write the equation of the parabola and also to graph the parabola. So again, this is just another close-up view of this parabola here, where this is the vertex. It lies halfway between the focus and the directrix line. So I could mark this distance congruent to this distance actually with 3 markings, since we already have some other markings there. And as you travel to the right, if I stop at this point is equal distance away from the focus as it is from the directrix line. And again, as we continue to move up the curve, at this point here, this distance is equal to this distance. And this being the directrix, this being the vertex, this being the focus, and of course this line that's perpendicular to that directrix but that passes through the vertex and the focus is the axis of symmetry. Okay, next up is a picture of a parabola that goes up, down, right, and left. Now, these parabolas are all have a vertex of 0, 0, just in these cases, and I just wanted to point out to you that the p-value, if the parabola is opening up, the most important part is that the p-value is positive. Now, if you go below that and you look at the parabola to the right, the p will also be positive here. And so what that means is, no matter what, the distance from the vertex to the focus is the same as the vertex to the directrix, but our p-value will actually be positive in the equation of the parabola. Versus when our parabola faces downward or to the left, we're actually going to make sure that our p-value is negative in the equation of the parabola. And so again, even though the distance, let's say, from this vertex to the focus, or this distance from the vertex to the directrix always is actually a positive number, we make it negative because we are signifying that the parabola is either going down or to the left. Okay, looking at the equations, we are finally ready for that moment where we can look at two equations. One is for a parabola that has an axis of symmetry that is vertical. If the axis of symmetry is vertical, that means the parabola is facing up or down. And if the parabola is facing up or down, then you will start with x minus h squared, which I know seems strange because most people want to think that starts with the y minus something squared, but it's actually x minus h squared, and you'll notice that this is actually a binomial. So keep that in mind as well, because we are going to complete the square for parabolas. So x minus h squared comes first. It's going to be equal to 4 times p. Remember, p is that distance from the vertex to the focus or the vertex to the directrix. And depending on if this parabola goes up or down, this p will be positive or negative. If the parabola is up, then this p-value will be positive. If this parabola is facing down, this p-value will be negative. And then you write y minus k. So what you need to fill in for the equation of the parabola is always your p-value, and then decide if it's positive or negative, and then also your vertex, which is h and k. Now, these last two boxes here deal with describing where the focus and the directrix goes, and so you can use this as a reference, but I will go over this as I teach you some of the examples, so I won't read through this, but use it as a reference. And then let's go to the second equation. This equation will be used when you have a horizontal axis of symmetry. That means your curves open either left or right, okay, for the parabola. And so you will actually, if it opens left or right, you're actually going to start with y minus k squared, that binomial squared, equals 4 times p. And remember, if the parabola is opening to the right, p is going to be positive here. If the parabola is opening to the left, then p will be negative here, and then that will be multiplied times x minus h. And again, plotting the focus and the directrix, the hints are here, but we're going to go over it in the examples that I do. And lastly, what happens when the vertex is at 0, 0? If the vertex of the parabola is at 0, 0, that means your h and your k is at 0, 0. So when you have an axis of symmetry that's vertical, which means you have a parabola that's up or down, and you plug in a 0 for h and a 0 for k, then you simplify this equation all the way down to this, where x squared equals 4py. And the only thing left you have to plug in for is, of course, your p-value. Again, this is only when the vertex is at 0, 0. And you can also use these hints to find the focus and the directrix, but it's easy to do on the graph, and I will show you that in the examples. And then let's just go down to the other equation. When your axis of symmetry is horizontal, that means your parabola is either facing to the left or to the right. And if your vertex is at 0, 0, if you plug a 0 in for h and a 0 in for k, well, that simplifies this formula to this, which is y squared equals 4px, which means that, again, the only thing you need to plug in is p. And you'll decide if that p is positive or negative by deciding if it's going left or right. Again, these hints you can follow, but you don't actually have to memorize this because you will understand where everything is graphed when we do the examples. And so we are almost ready to do these examples. The last thing we have to talk about is graphing a parabola. So when you graph a parabola, what will you have to graph? This is really important. You need a vertex, you need a focus point, you need your directrix line, and sometimes they will ask you to graph the axis of symmetry. It's not always asked, but sometimes they will ask that, so I guess this could have been added in. But the other important thing that I want to talk about is this. You will be asked to graph at least 2 points on the parabola. Now, why is that? Well, if you only have the vertex, how do you know how wide or how narrow your parabola is? You don't know unless you have at least 2 points, one on each side of the parabola, on each side of the axis of symmetry. And so, how do you find these 2 points to be able to draw that curve? Well, you could make an XY table. You are familiar with that, and you could plug in some values for X and solve for Y, or plug in some values for Y and solve for X. But there's also actually something that is true, a rule that's true all the time, and it's an easy way to find the 2 points on the parabola. You can actually calculate, now it's missing here, I don't know why, but didn't like my math equation, but you can calculate the absolute value of 2p. That should be in your notes. And if you calculate the absolute value of 2p, and you get that value, you can actually count that amount from the focus to the right or to the left to get the 2 points on the curve. So for example, in this picture, and here's my parabola, I have a p-value of 1, if you guys will agree, right? 1 unit this way, 1 unit this way, but my p is 1, and it's actually a positive 1 because the parabola, oops, didn't mean to draw that, but the parabola is going up. And so because the parabola is going up, my p is equal to positive 1. So that's why I say if p is equal to positive 1, then here's what we do. We plug it in this absolute value of 2p. And so if I plug up 1 in for p, that's absolute value of 2 times 1. 2 times 1 is 2. Now what do I do with this 2? What do I do when I calculate the absolute value of 2p? Well, I'm going to take that number, I'm going to start at the focus, and I am going to count to the right 2 units, plot the point, and then I'm going to count from the focus to the left 2 units and plot that point. Then I'm going to connect my vertex and those 2 points. Now you will do that if the parabola is up or down. If the parabola is opening left or right from the focus, then you're actually going to count up and down from the focus instead of right and left. Again, you will understand how to do this, exactly how to do this when we do the examples. Starting with example 1, it says to write the equation of a parabola with the vertex at the origin. So that's something important that I'm going to write down right away, that our vertex is actually at 0, 0. And if you remember looking over the equations of the parabolas, I only need the vertex and my p-value. So I know my h and my k, and I'll write that below so you remember that's h and k. What I need to figure out is my p-value. Well, I'm going to plot the focus point next because that's the next thing they give me, 1, 2, 3. And so this is my focus. I'll put a V for vertex and F for focus. Right now, I can actually say what the p-value is. I don't even have to draw that directrix line. I will later to show it to you. But right now, I know that the distance from the vertex to the focus is 3 units. So I know my p-value is equal to 3. What I don't know is if p is positive or negative. Well, the parabola that I have here must pass through the vertex, and the focus point is inside of that curve. So hopefully you'll agree that my curve should be out to the left. Now, I don't know exactly how narrow or wide my curve is. I don't need to find the 2 points on the curve, but I do know that my parabola is facing to the left, okay, or opening to the left, because it includes my focus point here. So because it's opening to the left, hopefully you will agree that my p-value needs to be negative because it opens to the left. And because it opens to the left, Then I want to decide what formula to use. Well, or which equation to use, really. If my parabola opens to the left, what that means is I have an axis of symmetry that is horizontal. I have a horizontal axis of symmetry. If I have a horizontal axis of symmetry, I actually start with y minus k squared. You can look back at your equations to be sure. And so I'm going to start with y minus k squared, which is y minus 0 squared, equals, I'm going to write 4 times p is negative 3, and then that's times x minus 0. And to simplify that, y minus 0 squared is y squared equals 4 times negative 3 is negative 12 times x, and that is the equation of your parabola. Now, I didn't actually graph the directrix because I didn't need to, but I do want to graph it for you to show you where it ends up. If x is equal to negative 3, then it would look like that. And just to clarify with you, the p-value is still 3. If I count from my vertex to my focus 3 units to the left, or I count from my vertex to the directrix 3 units to the right, the p-value is still 3. That didn't change. And the p-value is still negative because my parabola opens to the left. Again, I didn't need this piece of information, but I guess it's helpful and if you want to graph it. Okay, moving on to example number 2, I have to write the equation of the parabola with the vertex at the origin. And again, that's important because when we write the equation of the parabola, we need the vertex and we need the p-value. And so if the vertex is at 0, 0, that means the vertex is at 0, 0, which is hk. I can plot that here. This is my v for vertex. And again, they actually give me the focus and the directrix. What you're going to learn is that you don't need to plot both, but if you want to, you can. I'm going to plot the focus point first, just because that's the one they gave me. So I'll plot the focus, which is at 0, negative 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. And that is the focus point. And I'll explain why, but I don't need to graph the directrix yet because I can actually state what the p-value is here. Remember, p is the distance from the vertex to the focus or the vertex to the directrix. So if I want to count from the vertex to the focus, that's 1, 2, 3, 4, 5 units. So p is equal to 5. And the next thing we need to decide is p positive or negative? Well, looking at the vertex, and this is the focus, remember that curve has to have the focus point inside of that curve. And so the parabola must be facing down, and if a parabola is facing down, that means our p-value is negative. And so we have enough information to now graph or write the equation of this parabola. To write the equation, because this has a vertical axis of symmetry, which is here, vertical axis of symmetry, and it opens down, okay, then we're going to start with x minus h squared. So x minus 0 squared is equal to 4 times p times x minus, y times y minus 0. Sorry about that. So x squared equals negative 20y, and that is the equation of the parabola. Again, that directrix I actually don't have to graph, but if you want to, you go to the y-axis, 1, 2, 3, 4, 5, and go to 5, and you can draw that horizontal line, and it does prove to you that the p-value is still 5, and p is still negative because the parabola opens down. So this is just, I needed either the focus or the directrix, but I really don't need both in this example. Example 3 is great to do. You can pause the video if you'd like and maybe try it on your own. I wrote the key out to the notes so you can check your answer, but for time's sake, I'll go ahead and I will skip to example 4. Example 4 says to write the equation of the parabola with vertex 2, 3. What's important here is the vertex is not at the origin, so this is h and this is k, and the directrix is y equals 2. Well, let's plot the vertex, which is at 2, 1, 2, 3, There's our vertex there. And our directrix line is y equals 2. So I'm going to go to the y-axis and 2, and I'm going to draw that horizontal line there. That's my directrix. And because of what's given to me, I already know the vertex, which I'll rewrite here, which is 2, 3. That's my h and my k. And if I want to write the equation of the parabola, I really just need my p-value. Well, p is the distance from the vertex to the focus or the vertex to the directrix, and the vertex to the directrix has a length of 1, which means p is equal to 1. Now I just need to decide, is p positive or negative? Well, the directrix is under the vertex. Okay, it's below the vertex, which means the focus would be in the opposite direction. The focus would be above the vertex, okay, or up. If the directrix is down from the vertex, then the focus is going to be up from the vertex. And if the p-value is 1, that means if I want to plot it, I don't have to, but if I want to plot it, that means my focus would lie here. And as a visual, that means that our parabola would be opening up. Okay, it opens up. This parabola is not going to intersect the directrix at all, okay, but it is going to include the focus point inside of that curve. And so if the parabola goes up, then our p-value is positive, and we want to keep that a positive 1. What that means is our parabola opens up. That means it has a vertical axis of symmetry, and if it has a vertical axis of symmetry, you actually start with x minus h squared. So we are going to write x minus 2 squared using our formula equals 4 times p, which is positive 1, times y minus 3. That's y minus k. And to simplify this, we'll leave the x minus 2 squared here. 4 times 1 is 4, and then times y minus 3. This is the standard form equation of the parabola. You do not have to FOIL this out. This is the standard form, so you want to keep it in this form. Okay, this is your answer for example 4. I am going to skip example 5. It's just another repetitive problem, but if you would like to stop the video, try it, check my key online, and then move on, you are more than welcome to do that. I would like to try example 6. So this says to write the equation of the parabola with vertex 1, 1 and directrix x equals 4. And just to remind you, we only have to write the equation. We don't have to graph all of the parts yet. That is coming up. Right now, we're just writing the equation of the parabola. If the vertex is at 1, 1, that means our hk is 1, 1. And I'll rewrite that over here, vertex 1, 1, which means h is 1 and k is 1. We'll go ahead and plot that. This is v for vertex. The directrix is x equals 4, so if I go to the x-axis and I count 1, 2, 3, 4, I graph that vertical line, x equals 4. That's our directrix, and so I want to find out what p is equal to. I am going to count the distance from the vertex to the directrix line. I don't have a focus, but that's okay. I'm going to count 1, 2, 3 units, and so p is equal to 3. The question is does p need to be positive or negative? Well, the vertex is here, the directrix is to the right. If the directrix is to the right 3, that means the focus would be to the left 3. And if I graph that 1, 2, 3, just as a visual so you can see it, you don't have to plot it, but if the focus is here, that means our parabola opens to the left. Again, you're just doing a little sketch of a curve. I don't know exactly how narrow or wide the curve is at this point, but it opens to the left, and if it opens to the left, then our p value must be negative 3. And now we need to write our equation. Well, our parabola opens to the left. It has a horizontal axis of symmetry, and if it has a horizontal axis of symmetry, you start with y minus k squared. So y minus, and you need to go to k, although h and k are the same, so it's just going to be y minus 1 squared equals 4 times negative 3 x minus h. To simplify that just a little bit, y minus 1 squared, keep that binomial on the left, that binomial squared, and then just multiply 4 times negative 3, which is negative 12 times x minus 1. That would be your answer for example 6. We are now at example 7. I am also going to do some skipping here. I have plenty of examples if you want. You may skip A and B, but feel free to pause and try them on your own and look at the key for help. I'm going to go ahead, skip A and B, and I will go ahead and probably actually skip C. I think so. I'm going to go ahead and skip C. So you may try example 7 as extra practice on your own. I'm going to go ahead and why not? Let's get to graphing. Let's go to example 8. So if I want to actually graph the parabola and I'm given the equation, then if I want to, I could rewrite this just for visual sake if you want to see it. I could rewrite this as y minus 0 squared equals negative 8x minus 0. Just to prove to you that my vertex is at HK and that vertex is at 0, 0. So vertex, I'm just going to make a note here, is at 0, 0. And I'll go ahead and plot that vertex there. You don't have to rewrite it to make it look like this. If you recognize that the vertex is at 0, 0 from the given equation, of course that's okay. Then from there, I'm going to, when I have to graph, I'm going to have to graph the focus point, I'm going to have to graph the directrix line, and the only way to get to the focus and the directrix is to find the p value. So I'm going to solve for p. Now, how do I solve for p? Well, this right here in the equation, okay, this negative 8, is represented by a 4p in the standard equation of the parabola. I hope you're following. So this actually equals 4 times p. So if I want to solve for p, I'm going to set 4p equal to negative 8. And by doing that and dividing by 4 to each side, I know that p is equal to negative 2. And this is important because if p is equal to negative 2, then I can get to the focus and the directrix by traveling 2 units away. The question is, which way is this parabola facing? And so because it starts with a y squared, that means our parabola is either going to open to the right or to the left. Okay, so because it's a y minus 0 squared, it opens to the right or to the left. But because our p-value is negative, that means this parabola must opens to the left. This parabola opens to the left. I can even draw a mini curve just to remind myself that this parabola is going to open to the left. From there, I can then travel from this vertex 2 units to the left to get to the focus point, because the focus point lies within my curve. Oh, I only traveled 1. Let's try that again. Let's travel 2. So 1, 2, right here would be my focus. So focus is at negative 2, 0. Okay, that's an important part of my graph. Also, the vertex is an important part of my graph. Okay, another important part of my graph is the directrix. So the directrix is a line, and I'm going to start at my vertex. I am going to, instead of moving 2 units to the left to get to my focus, I might have erased some of my parabola there. There we go. Okay, so to get to my focus, I traveled 2 units to the left. To get to my directrix line, I'm going to travel 2 units to the right. And therefore, this line here is my directrix. The equation of that line is x equals 2. Okay, next thing I may want to write about, possibly, is the axis of symmetry. And so I'll use a different color. Let's use purple. Axis of symmetry is something we could ask you for. And the axis of symmetry passes through the vertex and the focus, and it's perpendicular to that directrix line. So the axis of symmetry is actually the x-axis. The equation for the x-axis is y equals 0. Now that's another important piece that could be asked of you when you graph. And lastly, to be able to graph this parabola, what I am missing are the 2 points on this parabola because I don't know how narrow or how wide this parabola gets. So I am going to calculate that absolute value of 2p. I'm going to do that in this teal color. So to find the 2 points on the parabola, we are going to calculate the absolute value of 2p. Well, what is the absolute value of 2p? Well, that's the absolute value of 2 times our p-value, which is -2. And that's the absolute value of 2 times -2 is -4. The absolute value of -4 is +4. Okay, what this tells me, what this number tells me, is that if I start from the focus and I count 4 units up and 4 units down, I will lie on the curve. So I'm going to graph 1, 2, 3, 4, the point 4 units up from the focus, and the point that is 4 units below the focus, and those are actually the 2 points on the curve. And to label those 2 points, I'll call that -2, 4, and -2, -4. And to actually sketch out my curve then, I want to make sure that my curve contains those 2 points. And that is how you graph the parabola. You include the vertex, the focus, the directrix, the axis of symmetry, and at least 2 points on the parabola. Okay, example 9 is of course similar to this, so I would like to skip this, take a look at the key, you can use it for practice. I would like to go to example 10. Let's graph this parabola. So this parabola starts with x minus 5 squared equals -8y plus 2. This represents my h value, this represents my k value, and so my vertex is at hk. Now remember, the formula is already negative, so when I say that x minus 5 squared, and I'm asking you for h is actually a +5, because again, the formula is already, oops, didn't need to use the pen yet, the formula is already minus here. So vertex, +5, -2. Okay, that's an important piece of this parabola. 5, 1, 2, 3, 4, 5. I'm going to graph that right there, and -2. Now, because it starts with an x minus 5 squared, okay, that tells me that it has a vertical axis of symmetry. And so it's going to open up or down. And the way I'm going to be able to determine that is by finding out what my p-value is equal to. Looking at the equation, I guess we're actually, sorry, this happens to be another -8, but that's okay. This here represents 4 times p. So what I want to do is set 4p equal to -8. It's not always -8. I know in the last example it was too, or the last one we did in example 8 was -8. But anyway, p again is -2 here. So if p is equal to -2, that means that this parabola, remember we said it opens up or down, it's going to open down. And if it opens down, that means I can find my focus and my directrix. Let's start with focus first. My focus point is going to be, well, let's actually graph a little mini parabola here just to show this. That means my focus is going to be 2 units below the vertex here. This is the focus. And so I'll write the coordinate here. The focus will be at 5, -4. That's an important characteristic. We also want to be able to graph the directrix line. The directrix is going to be found by traveling from the vertex in the opposite direction. So instead of going down to get to the focus, we're going to go up 2 to get to the directrix line. And so the directrix line is here. It's actually on the x-axis, which again makes the directrix y equals 0. Okay, after that, they may ask you to graph the axis of symmetry or state the axis of symmetry. This is another characteristic, axis of symmetry. Well, the axis of symmetry must pass through the vertex in focus and obviously be perpendicular to the directrix line. This would be the axis of symmetry, which would be x equals 5, that vertical line. And I would be almost done graphing, except for I need to find 2 points on this parabola. So to find the 2 points on the parabola, what you are going to do is you're going to calculate the absolute value of 2p. And the absolute value of 2p would be the absolute value of 2 times, again, we have that same p value, so negative 2, which is equal to the absolute value of negative 4, which is equal to positive 4. And what that tells me this time, though, is that from the focus, I need to travel 4 units to the right and 4 units to the left to get to the 2 points on the curve. Okay, so I'm going to start at the focus and move 1, 2, 3. I'm a little bit off the graph here. This would be one of the points. And 1, 2, 3, 4. This would be my other focus point. I'll record those for you. That's going to be 9, negative 4. And that's going to be 1, negative 4 for the 2 points on the parabola. And then, of course, you want to finish sketching out that curve. Just make sure that curve passes through those 2 points. And voila, you've got the graph of a parabola. It brings us to example 11, which is another repeat, so practice if you want. Check out the key online. Let's look at 12. I could do either A or B, so let's go for it. We'll just try example A. This is to classify the conic, and so that should jump out to you as, oh, I need to use b squared minus 4ac to figure out which type of conic this is. And then after we get the equation in standard form, then we can graph it and find the vertex, focus, directrix, and axis of symmetry. Of course, the 2 points on the parabola as well with the given equation. Looking at this, you cannot tell that it's a parabola except for one big hint is you only have one variable squared. So if it's going to be a conic, you could guess it's a parabola because you only have one variable squared. But let's go ahead and actually plug it into the discriminant just to be sure. So b squared minus 4ac, which is equal to b is in front of the xy term, which we don't have, that's 0 squared, minus 4 times, remember a is in front of the x squared term, that's a 1, and c is in front of the y squared term, which we don't have, so that's actually a 0. And what happens is this becomes 0 minus 0, which is equal to 0. And because our discriminant is equal to 0, that means, of course, we have a parabola. Sure, you guys are shocked. That's our parabola. Now, the problem is this is not in standard form. I don't know where the vertex is. I don't know how to find my p-value. And, of course, the goal is then to get this in standard form. Standard form for a parabola means I need to get that binomial squared on the left, and I need everything else on the other side of the equation. So watch what I'm going to do here with this equation. I am going to keep the x squared minus the 4x on the left-hand side. I am going to subtract 4y to both sides, and I'm going to subtract 8 to both sides. So my equation now looks like this. Okay, next, what I'm going to do is I want to complete the square for these two terms so that I can factor it and get a binomial squared. So on the left-hand side, I'm going to write x squared minus 4x. To complete the square, I'm going to add that special amount, which we'll talk about what that is in a minute, equals negative 4y minus 8. And remember, we need to keep our equation balanced, so I'm going to have to add the same amount to the right-hand side. Now, how do we get this? Well, remember, it's always b, which is negative 4, divided by 2 squared, right? This is our b coefficient in front of our linear term. So negative 4 minus 2 is negative 2 squared is positive 4. So I'm going to add 4 to the left-hand side. If I add 4 to the left, I must add 4 to the right. Okay, what do I do next? Well, the idea is once I get this to be a perfect square trinomial, which I just turned this into, I can now factor it. I'm just rewriting it, but I'm factoring it. And this is equal to x minus plus or minus something squared, that's going to depend on what our b value is. Whatever b is divided by 2. Well, negative 4 divided by positive 2 is a negative 2. So this is x minus 2 squared equals negative 4y minus 4. Okay, we're getting close to standard form. The left-hand side looks good. It's a binomial squared, but I need the coefficient in front of the y term to be 1, because that's what the standard equation of this parabola is. So what I need to do is factor out a negative 4 so that I am left with y plus 1. Now this equation of the parabola is in standard form and I can graph it. I will save you that on this video and suggest that if you want to practice graphing it, look at my key on the online and you can fill that out. You can also try example B if you'd like to try one more time. Otherwise, go ahead and try the homework for 13.4. The key is always posted for that as well. And if you have any questions, you can always message me. Have a great day. I'll talk to you soon. Bye.